This is part 3 of a HVAC schematic video series. So in in the first one of this series, we did a basic schematic with a double pole switch or a single pole switch, double throw switch that sequenced two light bulbs on and off. In the second one, we added a transformer to that and a relay coil. In this one, we're going to be drawing a ladder schematic of 3 light bulbs in series, controlled by a single pole switch, with a second single pole switch that bypasses one of the bulbs. Okay, now a bypass circuit basically routes electricity or current flow around an object, but does not create a direct short circuit. So let's start off again by our basics. Okay, we know we have a single power supply. It doesn't say anything about control voltage. It doesn't say anything about low voltage. So let's go ahead and draw in our line 1. Okay, I'm going to go ahead and draw in a safety switch. I'm going to go ahead and draw in my neutral. Okay, and let's go ahead and just label this since I already have this here. We'll say this is L1. We'll label this switch SS for safety switch, and we'll come over and label this neutral. Get in the habit of labeling things as you go. It will make it easier and you won't forget something. Now, we know we have 3 bulbs in series. Remember, in series means single path for electricity to flow. In parallel means there's 2 paths for electricity to flow. So let's go ahead and we'll give our 3 bulbs in series. Let's get rid of that odd-shaped one. And let's just move this in series. Okay, so I have my 3 bulbs in series. Okay, and they look pretty well lined up. Now, it says controlled by a single pole switch. So anytime we have something in series and it's controlling it, we can just draw in a single pole switch. So let's go ahead and draw in our single pole switch. Actually, let's go back to a line. So we're going to go ahead and we're going to create our single pole switch. And I'm just going to connect the load side of that switch. Okay, and we're just going to go ahead and connect these 3 bulbs real quick because we know they're in series, and I know I have to connect it to neutral or nothing will happen. I have to connect the line side of switch 1. We'll go ahead and connect that up. Okay, again, let's go ahead and label things. Okay, so this is SW1 for switch 1. We'll say this is, I'll come in here and say that is B1, B2, B3. Okay, so now I've made part of my thing. Okay, 3 bulbs in series, controlled by a single pole switch. Now it says I have to have a second single pole switch that bypasses one of the bulbs. Now bypass means taking something around it. Okay. For example, a bypass on a highway, you're going around a city. In this case, we need a bypass that's going around one of the bulbs. So let's go ahead and draw a switch in parallel to bulb 2. Okay, so I'm going to come in here. I'm going to have my switch there. Okay, so now when I put this in, okay, I can come in here Let's go ahead and label it, and then we'll talk about it. Okay, so we now we've met our schematic requirements. We have our switch 1 that controls bulb 1, 2, and 3. I have a switch 2 that routes the power around one of the bulbs, okay, bypasses. Electricity will always flow in the path of least resistance. So when the switch is open, the electricity has no place to flow but through bulb 2. However, when I have a bypass switch that's closed, that's a 0 ohm path, okay, has very low resistance. The bulb has resistance. The current is going to choose to flow through the bypass. You're going to see bypass current circuits used in different areas of HVAC. You're going to see it used in some oil controls, some gas controls. You're going to see bypass used in electric heating. Okay, electric heat strips inside an electric furnace or a heat pump. We will occasionally use a bypass circuit. Okay, so a bypass circuit, all it is a switching device. Could be a switch, could be a contact, could be anything, passing through one of the loads. Now, we know that L1 to neutral in this case, it's a 120 volt circuit, okay? When all the bulbs are functioning, that might be split up to 40, 40, 40, okay? And all the bulbs will be dim because remember, series circuit, the bulbs all share the voltage. So if the bulbs all have the same resistance, it would be broken up 120 divided by 3. However, once I bypass bulb 2, I now only have 2 bulbs in the circuit, bulb 1 and 3. So the voltage is now, instead of divided by 3, it's divided by 2. Again, if these are equal resistance. So each bulb now gets 60 volts and 60 volts. Go ahead and try it in shop. You'll see how it works, okay? But a bypass circuit, anytime we're talking about a bypass circuit, you're using a switching device to bypass one of the loads. Now, a lot of people are tempted to do this, okay? But don't do it, okay? So this would be incorrect. Okay, if I connect that into there, okay, that's incorrect because this switch then would close and create a direct short circuit that would blow out a transformer or a circuit breaker. So always make sure that every path of your circuit has, okay, a source, a path, which is my wire, a switch, and a load someplace along the way. Also, in HVAC, do not put any loads in series unless you're specifically told to. Most of HVAC uses switching devices in series, but not loads.